What is up, everybody? What is up? It is Michael Ward. Welcome to another episode of the Longevity Game Podcast. We are about to have a lot of fun. Going to talk about some cool stuff today. This is probably going to be the most mind-blowing of all the episodes so far. So buckle up, grab a piece of paper and pen, or your iPad, or just take notes on your phone because you're going to learn. You're going to want to keep this stuff. Yeah, you're going to want to refer back to some of this stuff today. Well. All right. So, hey, friends, welcome to the Longevity Game Podcast. I'm your host, Michael Ward. And today we're going to explore one of the most exciting and mind-bending ideas in modern science, okay? Can the aging process be slowed, paused, or even reversed? To get there, we're going to talk about a few things. Why your genes are not your destiny. How epigenetics controls aging. What we can learn from the only animal, the only creature on Earth that can hit the reset button on its own body, the immortal jellyfish, and how cutting edge research from Yamanaka factors to cellular reprogramming is giving us clues to the human aging that it may be more flexible than we thought. And so, let's get into this. This episode is actually inspired in part by the book Jellyfish Age Backwards by Nicklas Brendborg. If you haven't read that book, it's a really, really cool book. And it's not dry. It's not boring. It's a page turner. It's really good. He's done a really fabulous job on this book. You can get it on Audible. You can get it, on Amazon. It's a good book. Jellyfish Aging Backwards by Nicklas Brendborg, Borg. In this book, he looks at some of the most unusual, extreme, and just fascinating biology in the natural world. All right, so let's get into that. Let's start with what is epigenetics? Let's start with epigenetics. Okay, before we even get into the jellyfish, we need to lay the foundation. All right, epigenetics is the language that controls your DNA. Most people think of DNA as like a fixed script, right? But that's not true, right? We're learning more and more that your DNA is more like a giant library. And epigenetics is the librarian that decides which books get opened, which books get closed, which pages get bookmarked, and which pages are skipped, right? And so your genes can be turned on or off depending on the signals that your body receives from your lifestyle. This should be good news, right? Okay, sleep is a signal, exercise is a signal, nutrition is a signal, the stress, hormones, toxins, inflammation, all can cause different changes, right? These signals change how your genes behave, not the genes themselves. One major epigenetic system is DNA methylation. Okay, it sounds kind of complicated, right? DNA methylation. And you may have heard this before, but really haven't had somebody be able to explain it to you exactly what it is. But here's the simple version, okay? Think of methyl groups as like little sticky notes, right? And they attach to your DNA. Add more sticky notes, the genes quiet down, right? Remove sticky notes, and the genes become more active, right? So every time as we age, we collect more bad sticky notes. Does that make sense? And lose many of the good sticky notes. And so this sloppy pattern is one of the reasons that aging cells behave less efficiently. And we'll go into that. Another way these signals work is they alter histones. People hear that word and they freeze, right? Histones, like what is that? But here's a simple way to explain histones. All right, DNA is insanely long, right? Every cell in your body, all the trillions of cells in your body, have about 6 feet of DNA packed into a microscopic space. And histones are like spools that your DNA wrap around, right? And so, depending on the chemical signals your body gives, histones can tighten the DNA, making genes harder to read, or they can loosen the DNA, and this makes them easier to read. Okay, so histone modification is an alteration that can occur that can move aging forward or reverse aging or halt aging, right? these are tiny chemical changes to these spools, and they can just completely change which genes your cells actually use, right? So that's pretty cool. Epigenetics is a pretty new concept for a lot of folks. In one sentence, I think epigenetics goes like this: Epigenetics tells your DNA what to do. And aging is largely really the result of epigenetic shift, or I'm sorry, an epigenetic drift. And so it is complicated. It's a complicated, it's hard to wrap your mind around. But genetics isn't exactly. We look at twin studies, right? And some twin studies also show that identical twins have the exact same DNA, and if you were to split them up, and we actually have twin studies where some twins haven't even met each other their whole life until, in their third or fourth decade of life. And we can see changes that occur in their body that's different. They may have accelerated aging in one twin than the other, and that's because of epigenetics, the lifestyle, the things that have altered those chemical signals in the DNA methylation and the histone modifications that occur change how this person ages. But they should change, they should age the same. If we just think, hey, genetics is genetics, that's not the case. And this is very, very exciting, right? Let's talk about epigenetics, um, or epigenetic age versus chronological age, which is actually the number of years you've been on the planet, right? Your chronological age is the number of birthdays you've had, right? And your epigenetic age is how old your cells actually behave. All right. So scientists measure this by analyzing methylation patterns across your DNA. All right. And this creates your biological aging clock. All right. And these clocks predict longevity, disease risk, cardiovascular aging, cancer risk, cognitive decline. And here's the really amazing part: epigenetics can move forward or backwards. That's cool, right? So you can age yourself faster if you want to add some sleep deprivation in, if you want to become obese, eat over, all the junk, right? Chronic stress, if you don't want to do stress reducing techniques, you can really accelerate your aging clock because you're not getting the rest that you need. You're getting, cortisol, elevated cortisol levels, high inflammation, all that stuff is going to cause you to age faster. But you can slow or reverse your biological age through exercise, nutrition, hormone optimization, metabolic health, learning stress control techniques, peptides, certain supplements, and other lifestyle modifications, right? This can help you. This can slow or halt aging. And you just have far more control than you actually realize, right? But you have to be intentional in all these. Okay, you have to be intentional in this. The things that are easy to do are also easy not to do, and so you have to take steps. And you don't have to do all those things. You can do one thing and then get that down, then add another and get that down. So you want to do this as soon as possible. Because it takes a long time to develop a habit, right? And so whenever you add these things and they become habits, you're going to see major changes in your life, right? So super important intentionality in reducing all those things that can cause expedited aging. All right, so let's shift gears to that immortal jellyfish that we were talking about. This is one of the most incredible organisms on the planet. It's called Turritopsis dohrnii, right? And it's known as the immortal jellyfish because it has a superpower. When injured, stressed, starved, or old, it doesn't die. It transforms itself backward to a younger stage of its life, like a butterfly turning back into a caterpillar, or like an adult suddenly becoming a kid again, right? Scientists call this transdifferentiation, which means that one adult cell turns into totally different cell types. And this is really, really rare in nature, right? And so, why does this matter for human aging? You might ask. And the jellyfish essentially erases damaging epigenetic marks and resets its biological age. And this shows us a few things. Aging is not universal, right? It's not a locked in process. Biology can reverse certain age related changes. The epigenome is likely the master controller of aging and not just the genome, the epigenome. And this, don't make a mistake. This doesn't mean that humans are going to become immortal, right? That's not what we're saying here. But the jellyfish shows that reprogramming and biological renewal are possible. And so, with modern science, man, this gets really, really exciting. I mean, things are going to happen. We're in a great time right now. Like, there are some really incredible things happening in longevity, in health and longevity, and not a lot of people are talking about it in mainstream media. It's just a highly specialized, field of study and field of medicine. Longevity medicine is highly specialized, and so you're not going to hear a lot of this from your general practitioner, right? But this stuff is exciting, and there's a lot of things coming down the pipeline that I keep really dialed in on, and I'm really excited about it. And we'll continue to talk about those things, right? Let's talk about something called Yamanaka factors. You may have heard me mention this in the intro, right? And we're going to talk about how that helps to rewind the cellular clock. Okay. In 2006, there was a doctor, Shinya Yamanaka, and he discovered 4 genes. Now, those genes, now we know them as the Yamanaka factors, and they can reprogram adult cells back into youthful stem cell like state, right? Their names individually don't really particularly matter in this instant, but let me explain it to you like this. These 4 genes act like a factory reset button for cells, right? Turn them on fully, and it loses its identity and becomes a stem cell again. Turn them on partially, the cell becomes younger, but not erased, right? Isn't that cool? This is called partial cellular reprogramming. And so, why is this a big deal? Well, it means a couple things. Aging is not hardwired, right? And cells can regain function. Mitochondria get younger, and that's really important. DNA repair improves, and epigenetic damage can be reversed. And this has been tested. This is legit. This is real deal. I mean, it sounds like something that's made up, but it's not. This is real life stuff, and it's really exciting. Cellular reprogramming experiments in mice are a big thing. I think that you're going to find this pretty interesting. There was actually um, some things that are really jaw dropping when it comes to these mice studies. There was a study at Harvard, and scientists were using partial reprogramming to restore eyesight in old mice with damaged optic nerves. Their retinal cells, they literally became younger, right? Uh, Studies showed improvement in pair. I'm sorry, excuse me. Studies showed improved repair in muscle, nerves, cartilage, skin. I mean, life extension. Experiments in progerian mice that age rapidly. They showed a reversal of epigenetic age, healthier organs, a 30% longer lifespan. Let's just think about that. Let's say the average age of an adult in the United States is 75. Well, I mean, imagine living 30% longer than that. I mean, that's pretty amazing. That's and not just having 30% longer lifespan, but health span with that. Like you're just young again. Like all this stuff, you've reversed aged. So you're living a little bit longer. It's pretty awesome, right? Old cells regain characteristics of young cells, better mitochondrial efficiency, better gene expression. There was lower inflammation. I mean, it's just incredibly. Studies show that the epigenome, not DNA damage, may be the true driver of aging. And if we can modify that, we can make some big positive changes in our life. Slow aging, halt aging, or even reverse aging. That's really, really cool. This lines up perfectly with what we see in the immortal jellyfish. And so seeing that it's in the lab that this is actually working, this is a great springboard to human studies. Okay, and so what does this mean for human longevity? Well, I mean, we're now in a new era, right? I mean, my gosh, we're seeing like modifiable conditions, right? Not an inevitable decline. Like it's really incredible. So humans can already influence their epigenetic age through exercise, right? One of the strongest tools for stabilizing the epigenome is exercise, especially when it's strength training combined with zone 2 cardiovascular exercise. And so we've talked about the importance of strength training, building muscle. If you want to be more metabolically healthy, build a lot of muscle. And if you want to stay cardiovascularly fit and lose weight, zone 2 exercise is really great. And so that's where, if you haven't heard me talk about zone 2 heart rate training, it's like you take the number 220 and you subtract your age. And then you multiply that number times 0.6. And then you do it again. 220 minus your age, and then you multiply that number times 0.8. Now you have your range. You need to operate, your heart rate needs to be in that range while you're doing cardiovascular exercise. And that is zone 2 heart rate training. In zone 2, your body will preferentially pull from fat to burn for energy. It's the best. You'll lose more weight in zone 2 than any other zone. And that is the truth. That's a I guess that's as simple explanation as I can give you. All right. Also, what you can do is sleep and stress reduction. Sleep and stress reduction improves DNA repair pathways. All right. That's super important. Also, diet and fasting windows. Doing these things, diet and fasting windows, like time restricted feeding, right? Like you wake up in the morning and you don't eat until noon. And then you eat from noon to 8 for an 8-hour feeding window. And then you don't eat any more than that. You still need to stay within your caloric requirements and your macronutrient requirements in that time, which is easier to do when you have less time to eat because you just can't eat enough in that time, to actually to overeat, right? Some people have a fasting or a feeding window of only 6 hours, right? And so for 18 hours, they're not eating. And for 6 hours, they allow themselves to eat whatever they want. And so again, you always need to be mindful of your macronutrients and your calories. You don't want to exceed that. Always want to prioritize your protein. Anyway, so it reduces epigenetic noise and inflammation. All right. Hormone optimization. Man, we're hormonal people. Like everything that we do, we're it's hormone driven. Hormone receptors strongly influence gene expression. I mean, if you take out the thyroid, that affects every cell in your body, right? As you age, you make less testosterone. This is really important, especially in men, but also in women. And with women, as they age, they go through menopause. They start being very, very low, if absent in estrogen, and progesterone. And so these things are super important to continue those therapies. So hormonal optimization is really, really important. And then peptides. Oh my gosh, some peptides support mitochondrial efficiency and repair, and we've talked about those. These non-sexy peptides, MOTS-c, SS31. What's another one that will help? 5-amino-1-MQ. Those 3 peptides are really great at helping with mitochondrial efficiency and repair. All right. Yeah, which also helps maintain youthful epigenetic patterns, right? Some supplements like vitamin D, omega-3s, creatine, glycine, magnesium, NAD plus boosters like nicotinamide mononucleotide, also known as NMN, or nicotinamide riboside. These are precursors to NAD plus. And a lot of people get on NAD plus, or I get a lot of questions about NAD plus, and I'm okay. I don't have a problem prescribing NAD plus as an IM injection. You can go to these IV infusion clinics, and you can get IV infused NAD. But the studies that we have really don't show. We don't have a lot of studies on NAD plus like directly. Usually, the studies that we have on optimizing NAD levels revolve around those precursors like NMN and NR, and they work well. Right? You give your body what it needs; it assembles the NAD plus as it needs, and so NAD plus is great, but so is NMN or NR. Right? And you can also take NAD plus as a liposomal oral supplement. And if you're going to take NAD plus by mouth, you want to take it as a liposomal supplement because that is the most bioavailable form. All right. Also, another thing that you can do is avoiding accelerants. So toxins, smoking, chronic high blood pressure, high cortisol, all these things age the epigenome very quickly, right? So if you can control those things, reduce those accelerants, then that will help slow down, right? Your daily habits push your biological age up or down, right? Every single day. And again, this goes back to choices that you can make or not make, right? And so, anyway, final takeaway in all this is that aging is not a fixed destiny, right? Life has a built-in program for repair, renewal, and reset, right? Understanding the epigenome may be the key to extending health span, not just lifespan. And, the science being done today in epigenetic clocks, Yamanaka factors, cellular rejuvenation, it's showing us that, meaningful reversal of aging may not be science fiction. And there's a lot of cool things that are coming. We're living in a time when the biology of aging is being rewritten, and that's really, really exciting. So anyway, guys, I am really excited. I really appreciate you guys being around today. Thanks for hanging out with me on the Longevity Game podcast. If today's episode sparked your curiosity, or if you want to dive deeper into longevity, men's health, or performance medicine, be sure to subscribe on Spotify, YouTube, and Facebook. Share this episode with a friend who loves science. And if you're in Texas and you want a no-cost initial consultation at my clinic, visit nextleveltrt.com. We're a longevity and performance medicine clinic in Fort Worth, Texas. You can register online to take your body, optimize your choices, take care of them. Your genome and your epigenome is listening to everything you do. Make it count. If you have questions, business inquiries, you'd like to sponsor an episode, or if you'd like to be a guest on the show, just send us an email. Have a question about a topic or a particular episode, just email us at hello@the Longevity Game podcast. If you're interested in being a guest on the show, just email us at beaguest@the longevitygamepodcast.com. And if you're interested in supporting or sponsoring the show or an episode, just email us at sponsors@the longevitygamepodcast.com. And that is it, friends. I am out, and I appreciate you for hanging out with me, and I look forward to seeing you next week. You guys take care. Mike's out.
Bruh.